Hi folks, I just want to do a very quick note on how you do a flow duration curve. This instruction is actually on the lecture 23 water excess management field slides. So what flow duration curve really is, it is an exceedance probability plot. It shows you what is the probability that a value is being exceeded, and the probability is calculated as the rank over n plus 1, where n is the number of data points. Okay, just take this principle. We can go to our data. This is our data. We would initiate a column called the rank, right? Column called the rank. First, we want to rank the data. Okay, do sort data flow from largest to smallest. Do that, and then we have this data already sorted by rank. So, definition. The first guy is rank number 1, the second guy is rank number 2, and we can double click this, let it autofill the rest of them, right? And then the probability, we go to this formula, is their rank over n plus 1, okay? And so what is the maximum value here? What is the maximum value here? It's 5597, 5597, okay? Therefore, your n is 5597, right? Therefore, the probability P is the rank over n plus 1. Okay? Then you autofill this. Of course, there's something that you gotta do. You gotta fix the row number of this cell, and then you multiply this by 100, then you get a percentage, and you autofill that. You can see that it goes from 0 to 100%. Then I'll stop here and let you guys plot P versus the data flow. Okay, plot the two, and we will see a curve that looks something like this. Okay, it's a decreasing trend. It basically says at any given value, at a given percentage, the probability of exceeding it is on the y-axis, one of these data flows. Okay, all right, I just stop right here. Okay, then let's talk about problem number 2. Problem number 2 asks you to calculate the statistics for these different columns. Each column is a sample, right? For example, for this one we have skew, and you can calculate. This is a very straightforward application for this is the skew, right? Skew. Then let's do standard deviation. This is standard deviation, but we're going to do the sample one. Then you highlight this whole thing, and then you have the mean, right? Mean is simply the average of this, right? So we can calculate these statistics for all of these different columns. We are going to find that the problem asks you to comment on the reliability of the statistics. Okay, so do calculate this standard deviation for all these different columns, and you know the first 3 columns only has 20 data points. The last 3 columns has 200 data points. Right? When you only have 20 data points, is this value truly going to give you a reliable reading? Okay, it's supposed to give you back 0.4. It's supposed to give you back 2.4. Are these values reflecting that value accurately? Okay, are these skew reflecting this supposedly 0.3 skew accurately? What about when you have more data points, like 200 data points? Does the mean accurately reflect the supposedly background mean? Okay, so that's what I want you guys to comment on. Okay, then the problem asks, part B asks, if the annual data, the mass map skew is 0.33. What is the weight skew formula? Okay, what is the weight skew for sample A and F? And here, this is the formula that we need to use. Okay, we needed to the variance of the sample skew plus the variance of the map plus the map, and the numerator is the variance of the map skew. Do this weighted formula. This is basically what I want you guys to do. Okay, but the key here, okay, the key here is to remember that the variance of the weighted skew of the skew, sample skew, is not the variance of this column. Okay, it is not this variance. Okay, not this variance. If you do variance of this, you get if you do variance of this and you calculate, this is not right. This is not right. This is not the variance of the sample skew. Okay, this is the variance of the sample. It's not the variance of the sample skew. The variance of the sample skew is a measure of how accurate that skew estimate is from the sample. Okay, as a result, we are supposed to be using the formula that I introduced later. Here, the variance of the sample skew can be approximated by this formula. VGS equals to 10 raised to the A minus B log n over 10, where the n is the sample, the length of the sample data points, okay? And the length of the sample point, you can count how many, this is 20, okay? Length of the sample point, this is 20. And we know that the skew is 1.722. 1.722, so, well, sorry, 1.36. So it fits in this category. When you were trying to calculate A, it fits in this category. So A is equal to minus 0.52 plus 0.3 times the absolute value of the skew. Okay, and then B, because this is 1.36, is less than 1.5, so we select this formula. Okay, so B is equal to 0.94 minus 0.26 times the absolute value of that skew. Okay, and then you get this, then you use this formula raised to the 10th power of A minus B times log 10, where this n is 20. Okay, n is 20. Remember, if you're working on F, the n is no longer 20. Okay, take that, and that gives us 0.5173. This is the sample skew. Okay, this is the GS. However, you are supposed, oh sorry, this is the variance of the sample skew, VGS. Okay, this is variance of the sample skew. Then you go back and use this formula to calculate the weight. Then use the second formula, use this formula to calculate the weighted skew. Okay, so I leave those to you. And you do this for A, and then you do this for F. And you do this for F. Two separate values. They just tell us what is the value. Okay, let's say we have a somewhat unreliable estimated skew. What is the value of using the map skew to kind of regulate that estimate? Okay, so I stop here for questions, the problems 1 and 2. Thank you.